we follow the convention of defining the y direction along channel. So usually we use horizontal for x-axis and vertical is y-axis, right? But here in MOSFET, it is reverse. We always use along the channel I am going to represent y. So don't think when you represent y, it is vertical. It is going to be along the channel. Then C ox is a capacitance per unit area. The minus sign simply reflects that opposite charges are going to be induced on the other side of your capacitor. Otherwise, this minus sign has no significance, just to give a strong indication that negative charges are being induced on the other side of the capacitance. We are going to have this one. And we have several regions of operations of MOSFET. One is the linear region, or it is called as a triode region. So linear region is the region where output is proportional to the input. So the VGS is very large. So channel is formed large enough. VGS is very, very large when compared to VDS, or I can say channel is formed, but it is not starting to conduct. So when the point where the charge density becomes zero is equate the term Q of y to zero. So equate the term Q of y to zero, you get VGS minus V of y minus VT equal to zero, or I can say VGS minus VT equal to VDS, or I can say this difference in voltage is going to be equal to VD sat. So I put V of y equal to VDS because when I don't apply any voltage, or when I apply a minimal amount of voltage across the junction, this V of y becomes equal to VDS. So this is the boundary region for the triode region. The linear region is also called as triode region. The first region is we are finding the saturation voltage VD sat. As long as VDS is less than VD sat, the device will be linear. Linear means, as I said, output is proportional to input. So whatever input you give, it will faithfully amplify and produce the output. So we are finding out a special voltage called as VD sat. It is the boundary condition for your triode region. Triode region is called as linear region. So I am finding out the boundary condition for a triode region, which is VD sat. As long as the input voltage VDS is less than VD sat, the device will be in the linear region. Once this VDS is going to cross this VD sat, it is going to go into saturation, or it is going to go into the other region called as pentode region. Okay. So having derived the expression, so we have derived the expression for Qn of y. So now we can derive the expression for the drain current. So the current is given by ID, current equal to minus W into Qn of y into V of y. Since the channel is varying, the velocity is also going to vary. That is why you are going to have V of y. And sorry, this is not, yeah, this is velocity. So V of y, channel, it is voltage, sorry, not velocity, it is voltage. So Qn of y into voltage into W. W is your channel length. And voltage, it is equal to mobility into electric field. So all these basic formulas you should remember from the devices. Voltage is going to be mobility into electric field. And since it is an N-channel device, this voltage will be equal to mu N into E. If it is P channel, I am going to use mu P into E. And minus side indicates I am going to have negative charge induced on the other side of your gate region.